Please welcome Paige Crahan, General Manager of Tapestry, for a tech talk entitled AI at Work for Our Energy System.
I have the distinct pleasure of showing some real tools that we're using today where we have applied AI to our electricity system, and my hope is this inspires us all to work more fervently at getting this done today. As mentioned, I'm Paige Crahan, General Manager of Tapestry, which is our moonshot for the electric grid, incubated out of Alphabet's Innovation Lab. And there's a room full of experts here, but I'm going to ask you to indulge me in a journey to discover why we really need a moonshot. So let's talk about some of the most significant technologies that we use. And 100 years ago, when we first started thinking about these technologies, what did they look like? We were traveling from A to B in horse and buggy. We were communicating occasionally through telegram. We were just starting to generate electricity, centrally generating something that we burned, shipping it far away to where we used it to turn on a light bulb. The beginning of the electric grid 130 years ago. And what do those things look like today? Well, we have electric cars zipping all around, and in some places in the US, they don't even have drivers in them. Robots are driving them. We all have computers in our pockets that are transacting and communicating at a millisecond time horizon. And of course, in good news, our electric grid is centrally generating electricity, shipping it to where it was used in a one-way direction. So as you can see, the fact that the backbone of this core technology, the electric grid, largely looks the exact same as when it was invented 130 years ago is part of our problem. To get my slides back. There we go, perfect. In good news, we believe that AI can really help us solve this grid issue. But we need to understand, and I think we're going to hear some folks after me talking about all of the solutions that we have in generating new types of electricity, in using intelligent dispatch and demand response, shifting some of our loads. All of that work is beautiful, but the rate limiting factor is the physical grid itself. And when I say the grid isn't working for us today, I say that in a room where the lights are working, your phones are all charged, I hope. I know at conferences it's sort of hard to make sure they're charged. But we generally believe electricity is working for us. But if you examine what's really happening, the instances of outages have nearly doubled around the world, in the US as well. So we have more frequent outages than we've ever had, of course, largely driven by climate and aging infrastructure. We have the cost of power, so we now pay more for our energy, so we're investing in our system, we're delivering that new energy to our ratepayers who pay a higher energy bill, and we're building things for the grid, but it's taking longer than it's ever built before. So we talked earlier, I think Eric Schmidt and others have talked about how long it takes to build things in the US. All of that wonderful energy Secretary Granholm spoke about that we built in 2023, do you know how long those things sat in the queue before we installed them? They sat in the queue for 5 years before we installed them in 2023. And all while this is happening, we are emitting more than 25% of our global greenhouse gas. So let's reflect on what our grid is doing today, what's happening with the grid. Number one, we have lower quality of power and more outages. Number two, we're paying more for that power. Number three, we're taking longer to build things to fix it. And number four, we're contributing 24% of our climate change challenges. So if that isn't reason for us all to be here and show up and work on this problem together, I don't know what is. So why is that happening? People want to work on this, right? So let's make sure we understand how challenging this is. What are the grid operators, the utilities, the planners up against? This is increasingly complex. They want to do this work, but what are they doing? Starting at the bottom, we have skyrocketing demand. We've talked about this at this conference. This is both from, yes, AI, but before we were talking about AI, I would come to conferences like this 5 years ago. We talked about Bitcoin mining, then we talked about electric vehicles. I mean, we have been electrifying buildings and transportation and needing more electricity to drive our economy for many years. So while we're asking for more electricity on the order of the IEA thinks that we need to build 80 million kilometers of new grid by 2040, that's the same amount we have in the whole world now. We need more. We also need that to run in a totally different way than it was designed. It needs to be bidirectional. So we now have hundreds of millions of distributed devices that need electricity, and they are operating with electrical circuits that can use the internet. So these are 3 orders of magnitude more complex to model. So we're asking the grid operators who are already doing a Herculean feat of balancing mankind's largest machine in millisecond time horizon, we're asking them to do that in a world that's bidirectional and infinitely more complicated. And while we're asking them to please do this, double the size, do it in a more complicated world, we would really like to make sure that's completely run on renewable energy, which is really hard to predict, right? So now we're adding on top of that, please make sure that in something that is really challenging to predict, weather, I'd like you to get better at predicting that so we can manage this network. And we'd also like you to use that weather to think about how we use load. This is so challenging, we need to help. What are the tools they're using today? Great news, we have tons of data. We have a lot of data, but not a lot of information about the grid, not a lot of insights. Data doesn't always mean insights. On the left here, you see a grid operator. This is someone sitting in a control room. They will have 3,000 inputs at a given moment telling them what's going on the grid. It is not fair to ask that highly trained person to figure out which one of those 3,000 inputs they need to take action on. We got to do better. We're also using manual processes still. Right now, if you want a burrito, you can pull out your phone and you will have a burrito up front in probably 15 minutes, I bet. But the people who are running the world's most complicated machine are using single line diagrams. They're circling things to look at. They're emailing them to their colleague and say, hey, can you open that email and look at the element that I wanted you to pay, sort of give another look to? That's totally not acceptable for those heroes. And finally, we're doing wonderful work, but in silos. So we use spreadsheets to project, generation forecasts. Someone who's thinking about solar generation forecast and they're emailing it to their colleague who's going to download that and run a simulation, that's great, but that generation forecast is not being shared with the person who's thinking about demand. And if I know how the sun's going to work, I should also have a good idea about who's going to turn their air conditioner on, and those should be correlated. So to us, this is a data and information problem, and we want to work on that together. When I started working on this project about 7 years ago when I joined Google X, the sort of magic wand I wanted to wave, I was a renewable energy developer for a bunch of years, really wanted to bring this magical technical thinking. If you could wave a magic wand and build Google Maps for electrons, where everybody had high trust, it was intuitive to use, and the whole market really knew where electrons were, you could allow us to make much better decisions as an industry. The market would bring decisions to bear that meet the needs of our communities. And in really good news, there are tools today that allow this to happen. So the approach that we've taken is something that we refer to as a knowledge graph. A knowledge graph is a pretty familiar structure in data science and AI. In fact, it's used in many domains, but something that is, Google is uniquely known for. So when we use Google search, that is based on a knowledge graph that allows the search to gather a lot of information, correlate it, so that it is doing the hard work for you, the user who writes your query, hey, this is what you actually wanted to know about, pulling those informations and those data points together. So if we could create a knowledge graph for the grid, then we can make better decisions. And in really good news, the way that artificial intelligence has moved forward in the last few years especially, the ability to make this a reality, this knowledge graph for the grid, is real. So I am an energy nerd, and I hope some of you are as well. And one of the ways we're going to change this together is partnering with folks that are experts in different domains. So I came to X, which had a 14-year history of applying machine learning in the physical world. So the folks that I joined were building Waymos, flying drones, and coming into a room of experts and talking about what energy needs, and pairing with a group of folks who deeply know AI is how we create solutions. So we know that artificial intelligence, it's not a panacea, but it is a lever for the mind. And with a problem as complex as the one I just laid out, we need a lever for our mind. So now I'm going to switch to the showing, don't telling, which is I always tell my team, I don't want to hear what you're doing, I want to see what you've done. So let's talk about some demos and how is this put to work in the real world. I think a lot about technology does not equal product. A beautiful technology, something we put out in the world that we talk a lot about as research, does not solve a user's problem. A product has a customer and a user with a job to do and a value proposition where they will choose to use your product. This is where we've moved the technology into products. So at Tapestry, we think about the jobs to be done for our electricity network in 3 sort of large buckets. You're either managing your stuff, managing your grid. So am I getting the amount of solar out of my PV system that I expected? Can I predict an asset that's going to fail or rust or looks like it needs some maintenance? How do I make sure I'm thinking about the ROI of my assets? The second set of work to do is to plan for the future. And for years, this was pretty boring, to be honest. Flat load growth, you kind of knew when things were going to get built. We didn't really need to do things differently when you planned for the future. We're talking today about why we can't build faster in the US, it's the planning. These queues are because planners are overwhelmed. And you better believe if you ask any grid planner, do you want to go slowly? Do you not want to build the grid? They are doing everything they can to do this faster, but they don't have the tools. And if we want to do grid enhancing technology, deploy batteries, use virtual power plants, those planners need to see the technologies we're going to bring to bear. The third bucket where we deliver products is in operating. So while planning might be days, decades out, we look way into the future, 20 years or beyond, operating is milliseconds. Am I dispatching? How do I think about keeping the grid in balance? Or maybe 5 to 15 minute economic intervals. So the jobs to be done where AI can help, taking tech as into product, are in managing our network, planning our network, and operating our network. So I'm going to share 2 examples of where we've put these products to work in the world, because I promised some showing. The first is the tool in the management domain. This is a tool we call GridAware, which we've deployed in the US, we've deployed in New Zealand as well. And what you see here on the screen is synthesizing all of the information that we have, starting with Google Maps and a lot of the information that come from Alphabet and our partners' information. So imagery that maybe they've flown a drone program, maybe they've captured information on their own. We bring it all together in one view. And if you think about a tool like Waymo, the very first thing you had to do before you taught a car how to drive itself is get a really good map of where the roads are. So the very first thing we need to do is get a really good map of what this grid looks like so we can run these insights. So GridAware allows our users to get a better synthesis of what their physical network looks like. What we're able to do is apply machine learning to this imagery. I'll give you an example. So the utilities in the US, they generally know where their assets are, but they don't know everything about those assets. So here on these pins on the map, you see tags. What we've done is we've applied machine learning to their inventory of images. And here in this particular example, this is a utility in Michigan. They knew they needed to replace some of their cutouts, which is a component that ages, and you replace many per year. It's part of maintaining your network. But they weren't sure which of those cutouts were porcelain and which were polymer. Porcelain doesn't age well. Polymer lasts longer. So in order to reduce costs and fix the right cutouts, we could apply machine learning to show them which were porcelain, allowing us to minimize outages, allowing them to reduce costs, and be far more intelligent about running a resilient network. Here's another really delightful use of machine learning. So we took the cameras that are mounted on Street View cars, and we put a few on the utility vehicle, and we injected some machine learning and computer vision some smarts into that camera. And you can see in this image, this tiny little pin, it's 6 inches. So this is a camera that's driving down the road, 160 feet off the road, and the computer vision has found a 6-inch pin that has slipped through the bottom of the crossarm. A human won't find that, or they shouldn't if they're driving, I hope. So in good news, this is superhuman. This isn't replacing humans. This is giving them a fighting shot at doing the job we're asking them to do. So now we're saying in the tool, hey, you might want to go look at this. We're going to leave it to the experts to decide if this is something you need to fix right now, or maybe fix when you're on your next maintenance call. But this level of information, the automation of inspection, allows the utilities to have a chance of meeting their reliability and resilience needs at a low cost. Now I'm going to talk, so I talked about product and value. We need to build tools that make business sense. So this is a really great public use case because our utilities serve the public good. So we mapped about 4 million assets. And again, things like finding polymer and porcelain assets are really important. There's a metric we use in the US called SAIDI, which is an acronym because we love acronyms. SAIDI stands for System Average Interruption Duration Index. So it's the measure of how many minutes were you without power in that community. And every minute of SAIDI equates to a dollar value, an economic value for that community. So power outages mean people aren't doing business, mean your refrigeration is gone, so you have to, update all your produce. There's a real economic value to the community when you don't have power, and it is memorialized in this community as $3.6 million per minute. In Michigan, they connected the information we were able to share through GridAware with avoiding 3.7 minutes of outages, which again corresponds to a dollar value for the community. So that's real benefit for our communities. Now I want to talk about a second product, and then I'm going to give some conclusions. And like my children, I do not have favorite products, but if I were to have a favorite product, it would probably be this planning tool. And it's largely because I was in renewable energy development for many years, and before people like my mother knew what interconnection queues were, which I think everyone here probably knows what that word means is, I was wondering how the heck can we be in an economy where we have money and capital and we can't get this stuff built? We need to fix interconnection queues. So this is the planning tool that we've been working on for several years, and we've now deployed in the country of Chile. And I want to tell you about it today because in the US, the impetus of this conference is around being competitive. We've talked about building, we've talked about doing things differently. I want to tell you how we can do things differently starting today for building transmission networks in the US. So let's talk about why does it take so long? We talk about these queues and we're all upset about them. Well, what are the planners doing for those 5 years? I mean, they're smart, they're brilliant. Okay, so a planner is doing three things. They are creating scenarios for the future. So we are asking these people, can you pick a couple things that you want to simulate? Maybe high EV growth, drought year, and a lot of sunshine. And they have to hand create each of those scenarios. That takes weeks. After they create the scenario, they run it through a simulator. That simulator will run overnight. It's a lot of data that processes. They come back into the office in the morning and they see what the simulator said. Then they have a couple weeks of analysis. Okay, well that looks like there's going to be congestion. What will I do here? Because of how long this process is, it takes weeks to analyze one single scenario. So when we looked at where we wanted to spend our time, yes, AI is going to really transform simulation, but it's a relatively small period of the bottleneck we have here. So our team at Tapestry focused on the front end and the back end with the grid planning tool that we've deployed in Chile. We wanted to transform scenario modeling and analysis planning to 100x speed up grid planning for a national grid. And so 3 years ago, the Minister of Energy from Chile came to visit us in Mountain View, and he said, listen, we have a really ambitious decarbonization plan. We want to decommission all of our coal plants by 2040. Can your tool help us do that by 2030? So we've been working on this for 3 years, and here are some of the results. Last November, we shipped our first prototype. It is 86% faster than what they do today, and for the record, that is not AI. That is good old-fashioned technology, algorithms, and improving processes. AI isn't a panacea, but it's a component that will unlock all of this. Then we made their scenario creation easier. So that analogy I used where you do things by hand, so a planner was looking at about 12 scenarios because practically they didn't have time to run all the scenarios they wanted to run. Our ability to create those automatically, apply some insights to make that easier, that sped that up, not 30%, 30x. So instead of 120 data points, they're looking at 100,000 data points. And then finally, of course, we have applied some new forecasting leveraging AI, which I'll talk about in a little bit. Now, I promised a demo. So this is, you are a grid planner now. You're looking at your screen. You're a grid planner in Chile. You're logging in at the bottom. You found the scenario that ran last night. You selected it. You're looking at your 20-year time horizon of all of the transmission sections of your grid. You're doing it, the red is showing where you see congestion. This is something that won't work. You have a violation on the network. You're saying, and you're seeing the power flow on the side. You're saying, wow, I have a lot of issues at, the year 2027. You're moving to a 1-year map view, which allows you to see the entire country, but that specific line you want to analyze. Now on the upper right, you're seeing the congestion, and on the bottom right, you're seeing the spot price. So you want to know the cost of power at that price, and you want to know the physical challenges of the congestion. Now on the bottom here is something we call the scrubber. So using the same user interface as your iPhone when you zoom in on something, we're letting this planner just zoom in from his 20-year view into hour by hour, day by day. So this is 2026. This is four days, and on the left there, you see he's trying to see when does the red stop, when does the congestion stop, and it stops at 9 a.m. So that's not solar, that's wind. 9 a.m. is right when solar starts kicking on. So now he's got a little more information about what's going on here. So now he says, well, I want to see if I can fix this. Now that I think I know what the issue might be, let me go back to my planning tool. Let me grab one of the scenarios I ran yesterday or last week. Let me see if I can compare a couple different alternative transmission planning solutions to solve that violation. So he's going back to the simulation he ran last night. He's grabbing it, he or she, but happens to be a young man named Juan Carlos, so it's he now. He's pressing the compare button. He's saying, let me go back to this scenario that I ran that I want to compare it against. I'll grab it from my drop down. I'll compare these side by side. So here's my steady state on the left. Here's the alternative scenario that I want to compare. In Chile, we allow them to, of course, they sort both by north-south. Sometimes they sort by alphabetical order. Again, user interface is really important in products. So now he's comparing, okay, I want to see this one line, which is the Chura line. It's quite complicated. It's got these red boxes on it. It's the third from the bottom. He's putting his alternative scenario into the system, and then he or she is going to select run. And here you see third from the bottom, you've got yellow, yellow, and then a couple reds and yellow. And in his alternative solution, he solved that yellow in the year 2030 by whatever solution he's put forward. So now he knows this solution is going to remove a congestion issue, right? And this is just one snapshot of how we use these types of tools in Chile. Okay, how do we use AI? I hope that we talked a lot about the breakthroughs in artificial intelligence around weather prediction. Weather and energy are inextricably linked, both in demand, but also if we're using generation sources that are driven by water, sun, and wind. So when our colleagues at Google DeepMind launched GraphCast, transformational, amazing graph neural net weather prediction tool last year, we said, well, that's really cool. I wonder if we could tailor that for this planner in Chile. Juan Carlos in Chile loves to see this, research paper, but he doesn't know how to pull that into his day job. So we did the work of sort of what I would call that last mile. How do we take the amazing scientific breakthrough and make it useful for this grid planner? So we partnered with GraphCast, we partnered with the Chilean grid operator, and we said, what do you need to see to make this even better? We changed the model in 3 ways. One, we upweighted a few of the variables, like we put more weight on the wind information where there are wind farms. So the planner doesn't really care if there's no wind farm. He doesn't really care what the wind's like at that part of the country. He only cares what the wind's like where the wind farm is. So we upweighted those locations. We debiased a few of the variables. And then, working with the planner, what is currently in the model are measured variables. But we talked to the expert and we said, what else do you usually use? And they use derived variables. So he does some math on his own. So we inserted those into this model. And by making those tweaks, by tuning that amazing model, we got a 15% increase in the accuracy of that wind forecast. Let me give you some context. So in Chile, kind of like in California and kind of like in Texas, they are curtailing or not using a lot of their renewable energy because they didn't know it was going to come aboard. Last year in Chile, their curtailment rate went up 200%. So the amount of renewables they use went way up, but their confidence in when those renewables were coming is compromised. So the ability to provide 15% increase in wind prediction drives reduction in carbon. So now I'm not going to turn a coal plant on, but it improves the ROI of those wind assets that are already on the grid. We have to get out of pilotitis. It is something for us to talk about as a group here. When we pilot things, it's wonderful. We need to think about risk and deployment. But what's amazing about Chile is we delivered this tool in November of last year. They benchmarked it, they validated it, they worked with it for 6 months. And 2 weeks ago, they made the official commitment that they are using this tool in the country of Chile's national transmission plan for 2025. So they will use this with some of their other tools to inform hundreds of millions of dollars of national grid investment, impacting 20 million people's lives in Chile. So the Minister of Energy has been a great partner, and I want to just take 1 minute to let him tell us what his experience was like, and it's 1 minute.
La transición energética es en muchas dimensiones una transición de tecnología. Por lo tanto, tenemos que avanzar rápido en la implementación de tecnologías que están menos probadas.
Tapestry is weaving together the information, the technologies, and the partners needed to drive a reliable, affordable, low-carbon energy system. Ordinary's mission was to decommission their coal plants by 2040. They asked if we could build a planning tool together that would accelerate that by a decade. The grid planning tool transforms a process that could take a week or 2 weeks into 2 or 3 days.
Chile es un país que está en una posición privilegiada para aprovechar las oportunidades que vienen con la transición energética. Tapestry nos hacen redoblar el optimismo.
So aside from wanting to take a vacation there, which hopefully you do, we're really proud of the way they've deployed this technology, and it's been inspiring to work with that team. So I want to wrap up, hopefully with a little optimism that we can build these tools together. I want to issue a bit of a challenge for us, hopefully, while we're all together. So we know that bringing AI out of the lab and into the real world is going to be absolutely critical. We've seen really important technology transformations in the way Google Maps allowed things like Uber to become, amazing businesses, in the way Waymo became a reality. And now we think we can do the same thing with the electric grid. And very clearly, it's not going to be something that we alone do at Tapestry. We all are going to have to do it together, but we know we've seen these technical revolutions before, and we are in one right now. And there are 3 things that I think I would sort of drive as a call to action on this piece. One is we have got to get these technologies out of the lab and into the real world. And we have to work together on that. It is absolutely critical to move from tech to product. Number 2 is to trust the experts. We cannot sit in our silos and say, I know how to do this. Those grid planners must just not be very smart. Of course not. We have got to work with the people that are living and breathing these problems in partnership next to each other. And the third and final thing we need to think about is the business model, the commercial model. Research is wonderful. We got to use it. It needs to make sense. Our economy needs to want to use these tools. So together we need to think about how we drive these things. And I want to sort of end on one provocation. If I were you, I'd be saying, why did you do this in Chile and not the US? I hope you're saying that. I live in the US. And I want to just confirm, I did a little quick math of how many person hours my team was going to spend getting access to data in the US. It was hundreds of hours. Getting permission, filling out this form, and then more permission, and then I did a little math how long I was going to spend getting access to data in Chile. And the reason I can show you that demo is because all of their transmission data is publicly available. Go to their website right now. So my team was hundreds of hours at work into building this tool, where I would have been in the US still waiting for permission to get access to the data. So if we want startups and innovators to be able to do this work, we have got to remove the obstacles safely. I think the 3 things I would provoke us on this topic are access to data is really critical. Many people in this room are saying, what about security? You cannot compromise security when you deliver access to data, period. However, I would venture a bet that many of you took your iPhone out at some point today and paid for a coffee or paid for something by tapping that phone. Could you have imagined 15 years ago that all of your bank account information, your PIN number and everything was just in that device? I am positive that we can figure out how to share data and use security that works for us. The second thing is we got to build faster. We've talked about it a lot today. We have to figure out how to work together to permit and build faster. And finally, there must be trust in this section. This is not combative. We got to work together. We need national security. We need climate. We need jobs. We need everybody to come together and figure out how we're going to address this problem. So that's how I will conclude. I will offer a provocation. I watched a lot of Olympics this summer, so I'm now thinking about relay races. This is a relay race. It is going to take all of us, national labs, researchers, policy, government, public, private, and we're going to have to think across national security, economic interest and job creation, and climate to get this done. But like Secretary Granholm said this morning, if we do this right in this decisive decade, our kids and grandkids are going to be really proud of us. Thank you.